The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, everybody, and welcome along to DBA Fundamentals Down Under for the June edition. Once again, my name's Warwick Rudd, and I'm your host for this month's session. For this month's session, we've got Martin Catherall talking to us about JSON for the SQL Server Professional. I'll hand over to Martin very shortly. I do have some slides to run through as housekeeping for the monthly session. As per normal, this session is being recorded and will be available in a couple of days' time on the DBA Fundamentals archive website that you'll be able to come back and watch at any point in time. Throughout the session, if you do have any questions, you do have the question section that you're able to put those into. I will be monitoring those questions and will ask Martin appropriately throughout the session. So before we do start, a big call out to our sponsors. Without our sponsors, it makes it difficult for us to put these sessions on. And our first sponsor being SentryOne. If you haven't already been to their website, downloaded their materials, looked at their products, they have fantastic stuff there to assist you with your data platform learning. Our second sponsor, DBWatch, also has a lot of content available for you. Make sure you visit those guys, download their free stuff so that you can continue on your learning paths, which is what this is all about. Now, some of you may or may not have heard, but recently PASS announced that PASS Summit this year is going from a physical in-person event to a virtual event. Once again, like they started last year, there are path learning ways, and these are a sneak peek of some of the upcoming learning pathways that will be available as stepping stones, helping you to achieve what you're wanting to learn prior to and as part of PASS Summit. To find out more, you can go to the Learning Pathways page on the PASS Summit 2020 Learn. Also, there's not long to go. For those of us here in Australia, you've got another day because of we're ahead of schedule. But go into the prize to win a 3-day registration to PASS Summit. At this point in time, that's $500 US of free entry. Now, the cost of PASS Summit tickets is going up in a couple of days' time. So if you haven't already registered, make sure you register for the 3 days of learning later this year. Make sure that you do check out some of the top content which is coming from or available from last year's PASS Summit, that you can brush up on some of those fantastic sessions that were there last year. Just like this virtual chapter, there are many other virtual chapters that if you haven't already signed up and registered for you to learn about different things. As you can see here on the slide, there are quite a number that depending on what you're interested in. Go to the PASS website, look at the various virtual chapters, sign up and start your learning in those virtual areas. With that, we'll hand over to Martin for today's session. Okay, Mark.
G'day. Thank you very much for that. You can hear me okay there, Warwick?
We can, and we can see your first slide deck.
Okay, that's cool. That's cool. Okay, folks, welcome to JSON for the SQL Server Professional. We're just going to talk about some of the capabilities that have come to SQL Server in recent versions to do with reading JSON, writing JSON, and interrogating JSON. It's all pretty standard stuff for people who can find their way around T-SQL a little bit, but the session's really intended to just give you a taste and just to let you know what features SQL Server can implement for JSON, because it might be slightly different to what you're used to. And just give you a taste for what's there. So I'm Martin. I work with Warwick. I'm SQL Masters Consulting in Brisbane, Australia. I'm VP regional mentor for PASS in the area. Great job, Warwick, done giving you information there about the PASS Summit, and also a friend of Redgate. I can be contacted at my my personal email address there, martincatherall.com, or my SQL Masters address. And on my website there, I actually do have a little bit of a series going about JSON inside SQL Server that is probably about 13 or 14 blog posts in. I'll probably be adding quite a few more to that over the coming weeks. So do have a look at that, or drop me an email if you've got questions. Now, why learn JSON? Well, obviously, JSON has been around for quite a number of years. I think it sort of debuted about 2001. Obviously, I think most people at this stage have learned a little bit about JSON, if not using it in their day-to-day jobs. They're at least aware of it, what it is, and if they've seen JSON, they'd obviously know what it is. Very human readable and computer readable at the same time. Fabulous for data interchange, which is one of its chief reasons for existing. Lot of use on websites displaying data, and also it's actually a good bridge between the relational world, the world of tables and columns and that sort of thing, and the NoSQL world. CosmosDB, for instance, which is a NoSQL database, or MongoDB, heavily reliant on the JSON format. So being able to interchange data between one format and another is quite a good introduction to that NoSQL background. And I mean, SQL Server has now got JSON columns, as we'll see very shortly, and you can experiment there as you might with, say, Cosmos or Mongo before you get into that sort of thing. But we'll have a look at that as we go forward. So what are some of the real uses of this? Well, data engineering seems to be a really hot topic at the moment. And we've already mentioned transferring data from one format to another, but manipulating it at the same time. Do you want to manipulate it while it's in JSON, or do you want to put it in the database and manipulate it inside SQL Server? And there's options there for doing the same thing. And when people talk about data engineering generally, people tend to think about, you know, fancy things like SSIS, Azure Data Factory, Databricks, things like that. But it doesn't have to be like that. We can use like just what exists in SQL Server. And there's various things that have been introduced into the product over the years to help us with that. I mean, probably the most obvious thing is BCP. Pull in a CSV file, manipulate it in the database engine, do what you want with it, put it into a table. Later on, we've got XML, and now we've got JSON. And we've got a whole variety of things that we can use within T-SQL to do that job. So we don't have to rely on JSON, but as JSON came out in 2016, which is 3 versions ago now, but it's only like, what, 3 or 4 years ago, and people are still moving onto that 2016 platform. So hopefully this will give people a taste of what is in the product. So with some of the things we've mentioned within T-SQL, we've got Open Row Set. That can be used for dragging data from, say, the file system or from another data format, Oracle database, Postgres, even SQL Server. So Open Row Set is a very, very useful function, and we'll see that combined with some of our JSON data, and it'll be of tremendous use in probably half an hour's time when we get into a few of these slides. Obviously, as I mentioned, we've got the bulk insert and the bulk copy program, excellent alternatives. And probably the latest one that people who've never seen JSON inside SQL Server before, they might draw an analogy between XML and JSON. in terms of how it's implemented. That might actually be a little bit of a mistake, because the functionality for manipulating XML and JSON is implemented in different ways. And so one of the things that I've heard does put people off going anywhere near JSON in SQL is that they've struggled with XML in the past within the relational database, and consequently they don't want to go down that road again. Dealing with XML in SQL Server is a bit of a learning curve, I'd say, and even people who are very, very familiar with programming and that, it takes them quite a long time to maybe get up to speed with some of the functions and that exist for XML. The JSON support inside SQL Server is implemented slightly differently, and so it seems to me that it's a lot easier to deal with than XML. But we'll have a look at that as we move forward. So what are we going to look at in this session? Well, we're going to dive into Management Studio very shortly, and this is basically the last slide I've got before I summarize things, hopefully towards the end of the session. So we're going to look at like JSON and the data types that exist within SQL Server, and then transforming data from basically within SQL. How do we generate JSON from a table or from data that just exists there? But how do we read it in from disk? And once we've read it into disk, how easy is it to get into tabular format? How easy is it to put into a database and create a table? All the things we can do with JSON that we can't do with traditional SQL, there may well be. So this isn't meant to say that using JSON is better or worse than XML or CSVs or dealing with relational data in general. It's just aimed to give you an extra, say, tool in your toolbox. So let's dive in and have a look at SQL Server Management Studio and do some JSON. So I'll just create a database. I don't think we're going to actually need our own database for these demos, but just in case we do, I will create one. Now I'm actually using SQL Server 2019 here, but I've particularly gone out my way to use SQL Server Express to demonstrate that basically all the JSON features are available in every single SKU of 2019 and indeed 2016. So whether you're on Enterprise SQL or Standard Edition or even Express, as we are at the moment, you've still got access to all of the JSON features. And that's been true since 2016. So it may surprise you to know that inside SQL Server, there's actually no JSON data type. And so why are we talking about JSON at all? Well, if we rewind a bit to, say, SQL 2000, which is 20 years ago now, people start to experiment with things like XML, which obviously an analogous data transfer language. And there was no XML data type in the database at that stage. So what people would do is they would get their XML, which was effectively a string, a varchar max, for example, and they basically store it in the database as a string field. So the disadvantage of that is that the database actually knew nothing about the data type of the string. I mean, I knew it was a string, but it didn't care whether it was an XML string, a name, or anything. It's just a string in the database. And so you'd effectively get invalid XML in there. And if you wanted to manipulate it, you have to pull it out and maybe apply a different programming language or something like that. So when 2005 came along, we got the XML data type. And that was a full-blown data type. When we gave it a string, the string had to be in XML format or it would error. And we got a lot of functions and methods built onto that JSON, built onto that XML data type to analyze it and manipulate it. And as I mentioned a couple of minutes ago, that proved to be extremely tricky, however, extremely good to manipulate the data. So I think Microsoft might have learned from that and took a little bit of a different approach with JSON. So with JSON, it's basically a string, an nvarchar max inside a column in the database. So there's no JSON data type at all. So you might think, well, isn't that the same as it was 20 years ago when we didn't have an XML data type? Well, kind of, yeah. However, the difference is now that we've got a whole load of functions to deal with that string. So we can check if that string is valid JSON. We could get a value out of it. We can transfer it to a tabular format quite easily. So the first thing I'll do is show off this function here called isJSON. And here we've got a very, very simple JSON object. So we'll just see if that's valid JSON. And indeed it is. The isJSON function either brings back 1 or 1 for valid XML or 0 for unvalid XML. And so this is very much the same. It's one element of JSON, one object, but it's wrapped in an array. So we get our JSON objects in inside curly brackets and our arrays inside square brackets. So is this valid JSON? And yep, indeed that is. But what if we've got, and here's an array, 2 elements in here this time, or 2 objects within the array, and that is perfectly valid. But what if we've got an invalid JSON document? So here we've got an array there containing 1 object, and then we've got just an object below. So let's have a look there. And that's actually, yeah, that's invalid JSON. So this, as we can see, this isJSON function is actually quite useful to us. And here we have another one. Yep, that's not valid either. And back to some valid JSON down here. Even though it's nested, we can nest JSON as many levels as we like, really, which makes it quite useful in some respects, but can make it a little tricky to deal with in the database. So I would recommend when dealing with JSON in the database to make it 1 level deep. Now you can make it as deep as you want, you don't have to. But in order to make it easy for yourself, what I find 1 level down to be a great use for me. So that's the isJSON function. Now you can actually set up a check constraint in the database on your column to say, is this nvarchar max string that's going into the database, is that actually JSON? And if it's not JSON, we're going to kick it out and give an error message. So just want to introduce this string escape function. I'm probably diving a little bit ahead of myself here, and it's like kind of a chicken and egg scenario. What do I introduce first? But I've recently started using this myself. If you were going to say insert a string into a JSON document or craft your own JSON documents if you want to do that, one of the things you might want to do is escape characters, and string escape does just that for us. Now at the moment, you pass two values to it. The first is actually the string you want escaping, and the second is the actual format you want the return value to be in. Now at the moment, the return value format, it can only be JSON. So we can only escape a JSON string. And there's not that many characters in JSON that need escaping, but if you want to make sure your document is going to be valid, then you do want to escape certain characters. And one of those is actually a single quote. So let's have a look at what happens with a single quote. This is actually not going to bring back a document, it'll just bring back a string which would be valid inside the JSON document. And so we could see there that the double quote is actually escaped with the backslash character. So what if we've actually got a backslash in our JSON? How would that be escaped? And that would actually be escaped with another backslash character there. Now, occasionally we actually do want the backslash in the string, and an example here would be a non-printable character, and here we did the carriage return character, which I think is the ASCII 10. Yep, ASCII 10. So how would that be represented in the string there? And we can see it is actually a backslash and then an N. So the string escape format does that very nicely for us. And we can see here that in T-SQL itself, we actually have to escape the single quote character. Now, does that need to be escaped in a JSON document? And it actually doesn't. It's actually a perfectly valid character in the JSON document. But the string.escapes function there is obviously saying we've escaped it in a T-SQL character string, and that it doesn't need escaping in the JSON string. So are there actually better methods than that for creating JSON documents? And there probably are. So if we wanted, for example, to get all of those strings back in one go, could we just select them and call the string.escape function? And we actually could do that, no problem. Now, we have for XML that was obviously introduced in 2005 with XML, and we also have some for JSON arguments that can go on the end of our select. And the easiest one to deal with here is for JSON auto, which will basically give us a JSON document back in the format that SQL Server decides to give it. And so the select statement that we've just run there, we will run again with for JSON auto on the bottom. And we'll immediately find out that we'll get an error message back, because the for JSON auto statement actually expects the values to come from a table. So we can actually get them from a table, or we could just use a values constructor there with the for JSON auto argument on the bottom there, and we get back JSON in the selected column. I won't click on there for a moment. We'll have a look at that in a minute. Better way to do that might be to just set up some strings, put them in the values format there, and get them back again. And we can do that with any table we like. Here, I'm going to get the values from the sys configurations table. Notice that we've used the select star. So the elements in the JSON document will have come back with the names. And here we've actually explicitly defined the names. Now, I haven't clicked on any of these columns that have come back so far. And note that we've only got one column that's came back, and that is JSON. Now, you might be familiar with XML. XML would come back in a similar way. The difference is, if this was an XML column and I was to click on it, it would open up in a new window, and the XML would be nicely formatted in Management Studio. That unfortunately is not true with a JSON document. So I've just clicked on it, and there we've got a big string that's come back. It happens to be a JSON document, but you wouldn't know. So what I recommend you do at this point is find yourself a good online JSON formatter. And this is one that I particularly like, JSONviewer.stack.hu. So I just copied that string that's came back there, and I'm going to paste it in. And obviously it's all over the place. It's a big long document, but I can just go up and click the format button, and that's formatted it into a nice JSON document for us. And we can see that every single row we've asked for has actually come back as an object. And so we've actually got an array of objects that's one level deep. And so what's happened here is SQL Server has decided that we've used the JSON auto function. And so this is the format that we do, in fact, want to see the JSON in. But can we actually do anything different? Well, we can. We just run through a few things on JSON auto first. Obviously, we can alias any of those columns, and that will alias the name instead of what comes back from the column naturally. You give it a different name as you would in any other T-SQL. But you can literally piece together any sort of T-SQL you like and just add the for JSON auto clause on the bottom, and you will get back a valid JSON document. And you can run that through is JSON, and you'll see that it is in fact valid. But what if we actually don't want that? What if we actually do want a different kind of format? How do we go about doing that? Okay, so there is another clause we can use here, and this is for JSON path down the bottom. And if we in order to get a better shaped document, we actually use aliasing. And in, I guess, traditional T-SQL, when we alias, all we're really doing is giving the column a different name. And so if we've got a column called name and we want it called Morrison, for instance, we just alias it with the new name, and the column is called the new name. But the aliasing here inside the JSON path function actually relates to the name of the object and then the name of the column within the object. So I'll just actually run this because probably a demonstration of it is a bit better than an explanation. So I'll run that and we get back our string of JSON. I'll just grab that and I'll go over to our viewer, and I'll paste this in here. Obviously, very long string again, and I've formatted it. And we can see here that we've got the name of the object here is configuration property. And within the configuration property object, I've got elements that are called configuration ID, configuration name, value, so on. So each row has come back as a configuration property object. And so how has that actually been achieved? Well, what we've done with our aliasing here is we've actually used a dot notation. And so we've put the configuration property string first in the alias, then a dot, and then obviously the name we want it aliased with. So we've got the configuration property object and then the name. And that's all we've done. We've used for JSON path, and we've got the shape back. this works with whatever aliasing method you want to use, whether you want to use before and the equal sign or the as and afterwards aliasing. So that does actually work. If
Martin,
you were actually to do, yes.
Just before you continue on, we do have a question, and that question is: do you have to learn JavaScript if you want to use JSON?
Right. Yep. That is a very good question. Probably something I should have covered beforehand. Okay. So the simple answer is no. So obviously JSON is JavaScript Object Notation, and I guess it's got its roots in JavaScript. To manipulate it inside T-SQL to do what we're doing at the minute, no, you will not need to know any sort of JavaScript at all. If you want to get a bit more technical than we're probably going to get in this presentation, you might need to know a small bit, but it's so small that you don't need to go out your way and learn anything new. Basically, there's a little bit of, I'd say, different syntax for evaluating paths, and we're going to come to evaluating paths very shortly, but I'd say the simple answer to that is no, it won't hurt, but essentially you probably don't. But I'll just carry on from where we're at the moment. Hopefully that has answered the question. If you know T-SQL, you will probably be fine with any of this. What I'm demonstrating at the minute is it doesn't really get too much more complicated than this. But we can see here that if we actually wanted to have the same format come back, but we used for JSON auto, we wouldn't get what we expected at all. We just get basically a document with the aliasing done exactly as we'd expect it to be in the traditional T-SQL world with the elements like that. So don't get confused between for JSON path and for JSON auto. If you want to shape JSON yourself, use path. If you're happy with what T-SQL will give you, then use auto. I'll have a bit more of a look at this as we go along. And so, as you're probably seeing, however complicated your JSON is, or however simple it is, all you get back is one single element. And so let's just take a bit of a very brief detour and look at how we generally get back single values from a T-SQL script. So here, I just want to get the name back from configuration ID 101. And obviously, this is almost trivial in T-SQL. We declare a variable, and then in our T-SQL statements, we equate that variable to the name of the column we want back, and inside the value goes. Okay, so that's fine because this where clause here guarantees that we're only getting one value back. But what if we don't? What if it's not guaranteed that we get exactly one value back? So if I was to run this statement here, I'll just comment that and get the value back. This actually brings back some pretty similar statement to above, but it brings back a whole load of values rather than just one because it hasn't got the where clause on it. But if I run this again, we'll find that it'll just going to give me the last value that it came up with. And so that's probably not ideal, regardless of whether you're looking at JSON or if you're just looking at T-SQL in general. That is not that ideal. So a better way to get that back would be, in my opinion, to set the value to a subquery. And here we are definitely getting one value back. So we get the one value back we expect. And here, we will actually get multiple values back, and this will not work. Now, obviously, we've got an error there, but I guess you've got to ask yourself, is it better to get an error and deal with the error at the time, or is it better to bring back a value that's probably erroneous? And I guess that's a design decision for you in whatever you are going to do. But effectively, the reason I've shown that is because that is what we're going to have to do to bring back a value to SQL Server. Just let me look here. Okay, so we can actually use that method to get back a JSON document into a single object. And we can do a few things inside knowing that we can't do with traditional T-SQL. So here I've just got 3 queries, just against 3 system tables. And if I was to union that, obviously in T-SQL that is absolutely impossible because those statements bring back different values. Even with JSON Auto, I can't do that. And in fact, this syntax on its own is not valid because we cannot union JSON queries. And you'll see you get back a totally different error. This JSON Auto or JSON path is actually not valid inside a union statement. And so what could we do here? So what we want to do is take those 3 T-SQL statements, generate 3 JSON documents, and then combine those documents into one document. So we're just going to declare a value which will hold our finished JSON document, and we'll declare 3 other values that will hold our intermediate JSON document. And we're going to just set each of the variables to the value of that document using the syntax that I just demonstrated. When we've got all the values, we're just going to combine them all into a single JSON document, basically separating each array, because each of these is now an array. So we separate them by a column, by a comma, sorry, separate them by a comma, and put the opening square brackets at the start and the closed square brackets at the bottom. We should get back a valid JSON document. And SQL Server just brings it back this time as a string, but we can see if we were to paste that into our JSON formatter, that it is in fact a valid JSON document. But we can see up here, we've actually got nested arrays, and then we come to our object. This might actually be a bit of a challenge for us to read inside SQL Server, or inside anything really, as the arrays or the objects are named. So could we have actually done anything better there? And we may have well have been able to. So let's look at another addition to the for JSON syntax that we are given. And we're given this here called without array wrapper, which will basically bring you back the JSON document using JSON Auto or JSON Path, whatever you've asked for, but will omit the array, the beginning square bracket and closing square bracket. So you just use without array wrapper. So effectively what I'm going to do is exactly the same thing that we've just seen, just for each JSON document that I want back, I'm going to choose without array wrapper and then just wrap it in exactly the same square brackets that we had originally. And we're effectively going to get back, sorry, something's gone a bit wrong there. we're effectively going to get back exactly the same document. Well, not exactly the same, a very, very similar document, except this time what's going to be seen is we're actually omitted one level of nesting, which is probably going to make it a wee bit easier for us to get back should we want to query that document. So that's the that's without array wrapper. Okay, so moving on. What if we wanted now, we've seen how to take a table that's in SQL Server and generate a document from it and grab that document. What if we actually want to pick a document up from the file system? I'll just think I've gone on to. Yep. What if we actually want to pick a document up from the file system and have a look at it? And in fact, I've actually got a document over here. I'll just open it now. This document here, configurations just data. And it's pretty much what we've been looking at so far. Inside the viewer, it's the configurations table from SQL Server, and I've generated a document. So if I wanted to just pick that up inside SQL Server, how would I do it? And we're going to have to use the open row set function. And that basically is going to give us back one value and a bulk column. And so we can just run that, pick the document up, and here I'm just going to test if it is in fact a valid JSON. And our messages from over here will say, yep, it is, it's valid JSON. We picked up that document and it is in fact a valid JSON. I'm just going to comment that out. Now, if we want to read a JSON document that we've now got inside SQL Server, we pulled it in. It's came from disk, but it's now inside SQL Server. We will use this open JSON function. And this open JSON function might not actually give us back what we're expecting to get back. So let's just run it. We're just going to pull the document from disk and look at it. And what we get back is not the values at all. It's basically each column, sorry, each row actually represents one object from the document. And you can see that they're all numbered here. So this is called using open JSON with the default schema. We haven't actually defined the schema that we expect to get back. We've just used open JSON on its own. And so this is actually the default schema that we're getting back. And this has got tremendous value, in fact, because we could dive into the metadata from that JSON document and dynamically build up our own query to get the values if we wanted to. Now you'll notice that there we didn't specify any path to elements within the JSON document. Now the open JSON does actually allow us to do that. And here we're actually using a $, which effectively means the root of the document. So take every path from the root of the JSON document. And that will effectively give us back exactly the same thing as we got in the first query. So let's just, we'll just comment those two out, because now we actually want to look at actually getting some proper values back from the JSON documents. We actually know so far that in that JSON document, there are the values from the configurations table. We actually know in advance how that JSON document looks. So what we've added is a with clause, and we've said this is the schema of the JSON document, and these are the elements we expect to find within that document. So we just listed them out one by one. we've said the configuration ID is going to be an int, and it's found at the root of the document with a configuration ID. Second one, configuration name. Now that's found within the configuration property object, and it's called configuration name. Now, for the purposes of demonstration here, I've actually put in a space. Probably would advise you maybe not to go that route in real life. Whenever I'm naming columns or properties or anything, I prefer to like shy away from characters that are special or might cause confusion. However, I've actually put a space in here, but you'll notice that I've enclosed that name in double quotes, which has basically negated the space, and the same over here. So effectively, the with clause is the name that you want to get back, the data type you want to get back, and the path to that node or that element from the root of the document. And going back to the question before that Warwick asked about learning additional things, I guess this is the only, well, one of the only things that's quite crucial to getting values back from the JSON document. The $ indicates the root where we want to start, and from there we are basically just going down through the objects and the names of the properties. We set up here that we wanted to start at the root, but we don't have to start at the root. We could start at a specific named element if we want to. So that's the with statement and how we get values back from there. Yep.
Just before you go on, so with the $ being that it's showing coming from the root, is there any other special characters like the $ that may be able to be used for other parts of the path?
There may well be. I'm not aware of any off the top of my head, or I might think of some later. I actually prefer to always start with the $ and get everything from the root of the document. And one of the reasons I like doing that is, for example, we could have started at the configuration property, but then this property here would have been above it. And so there may be syntax to navigate up and down a document, a bit like a directory path where you can use double dot and dot and all that. I'm not familiar enough with the syntax to be able to answer that question categorically. The only thing I can say is that when I'm doing this, I always start with the $ and navigate down the document. And I always attempt to try and make the document only one level deep.
No, understand. So it was like when you copied up there and you said you wanted to start at the configuration property level, so $configuration property, down in your with statement, how would you show that if you were starting at that position, whether there was another character or whether you can assign it to that as your start point, etc.?
I just basically start with the at that level, with at the $sign there to you mean like that?
Yeah, so if you had it configured like that, that's where you were wanting to start, how would you have it down? So where you've changed the configuration name, would you just have it as the configuration name? Do you need to have any other symbol? Can you assign it to another symbol, etc.? And I guess then a follow-on from that is this syntax that you're showing, is this T-SQL specific or is this JSON specific?
Okay, all right, I'll deal with the second one first. This syntax here, this with syntax is actually starting to be, this is actually T-SQL syntax with an element of JSON syntax. So for example, the syntax here is actually navigating the path of the JSON document. So that is specific to the JSON document. The with syntax here is actually from T-SQL. And so it's a mixture of both. The with syntax is actually becoming a bit more common. If any of you played with Azure Synapse, there's something in there called SQL on Demand, and they have got a they've actually extended the open row set function to add this syntax to it, which is absolutely fabulous because you can obviously define the stuff that's coming back in the with statements. That hasn't made it into the box product yet. I don't know if it ever will, but yeah, we see this quite a lot. So it's a mix. I'd say it's essentially T-SQL syntax, but mixed in a little bit with how to navigate the JSON path. So let's just have a look. I've just altered that JSON path. I don't actually have an example of this straight off the top of my head, but let's have a look if this works. I suspect this syntax here may not work, but let's just keep our eye on the configuration name property there. Oh, sorry, I had that highlighted. And that actually gave me an error. So that error message that's come up there is related to this here, and I haven't got the path correct because even though it's asking to start there, it's not formatted correctly. So if I was just to start with a $sign there, that would work, but it won't give me back the row. So that actually is some different syntax for that, and I can't quite remember what it is, but I will look that up and I'll put it. I'll either answer the person who asked that directly, or I'll put it in my blog post series. But that is an excellent question, and probably something I probably should have a demo for going forward. Yeah, but just to carry on, I'm aware that we're nearly out of time. Took a bit of time there. We've seen that we get metadata back from the default schema, and we get the actual values back from the explicit schema. So can we actually mix the two? And the answer to that is actually we can't mix the two. We'll get an error. So there, I'm actually asking for one of the values that came back from the default schema, along with values from the explicit schema, and that's actually not possible. So a combination of the two is very useful, especially for generating, dynamically creating your own syntax. And that's something that I just want to touch on before we actually finish. So here I've actually got a document, just for demonstration's sake, I've defined it up here, and clearly we can see what it is and the values that are in there. But supposing we didn't know what those values were, how could we actually deduce what they were and build our own schema from the document? And what I tend to do there is I just tend to ask for the default schema. So the metadata that we've seen previously with the key and the value and the type. And then I will iterate through there in a cursor. And what I'll build is a select list. The select list is really quite straightforward. All we're really doing is grabbing the value with a key and appending a comma. The with list, as we see, is a little bit more intricate. What we have to do is grab the, see what type it is, which is in the metadata, and also see where the path is. And you can actually get those actually from the metadata. So let's just look here, just run that. So in this very, very simple document here, you can see that we've got the key, we've got the value, and it gives us the type. And there's only really 5 types it can be. Here we've actually got 3. We've got the value of 1, which is an nvarchar, a value of 2, which is an integer, and a value of 3, which is a bit column or a boolean. And so knowing that, we can actually piece together the JSON document. And that's exactly what I've done here. I printed it out in this case here. So we'll just run that. And over here, we can see that we've grabbed a select statement, which is in fact, which will in fact pull data from the JSON document. Now, clearly I've hard-coded things there for demonstration reasons, but that is quite a good way of deducing the schema of the document and just running it dynamically. So I just wanted to finish off with with 2 particular things. The first one is sharp-eyed viewers might have noticed there that the values of the values for things like the minimum, the maximum, and so forth are actually not these data types. So what do we actually want to do if we actually want to cast it to its own data type, which in this case would be an SQL variant? We can't actually do that in the with clause. We have to define what the data type is in the JSON, and they're clearly not ints. They will go to nvarchar columns, and that will be fine. But if we actually did want to put them back to a SQL variant, we could do that just simply in the select statement by try convert. So yeah, if you do want to get it back to its correct data type, to put it in table, avoid implicit conversions and the like, then using try convert in the SQL in the select statement is quite a good thing to use. So I just want to finish there on one other thing to notice. We don't have to use open row set or the with clause to drag back values from the document. If we know where those values lie, we can use a JSON value clause, and here we just pass the JSON document and the path to that that element within the JSON. Very similar to how we did with the with clause previously. Here again, I am actually starting from the top. That's something that I've like doing, just starting from the top. There's no way to start in the middle with this syntax. So starting from the $sign is quite a good thing. But there we have the JSON inside SQL Server, and so we're seeing quite a few things there. There's no data type within SQL Server for JSON. It's an nvarchar max, but you can use the isJSON function to validate it. You can get data back from a table within SQL Server quite easily using JSON auto and JSON path. You can read data from anywhere, really. Well, read data from the file system using open row set, but wherever you've read the JSON file from, you can still use OpenJSON, either with a default schema or with an explicit schema. And a combination of those things make it great for data interchange. I just put a note there about standards. I've been saying throughout the presentation that I like to get all my JSON back in a single element if I can. That just helps me know that I only have to interrogate at one level, no matter what JSON I pull back from maybe getting drives on a file system or data cards or whatever. That's probably more of a design decision than a technical implementation. But that kind of rounds out the presentation. So thanks for coming along. Thanks for listening to me, taking time off your lunch break to tune into the past DBA fundamentals chapter. And have fun, stay safe. And if there's any questions, Warwick, or anything more you want me to say, I'm happy to do that.
Thank you, Martin. Thank you, everybody, for joining us. As Martin said, we do have a couple of minutes. So if you do have any last-minute questions, quickly type those in and we'll be able to get those answered. So at this stage, Martin, we have answered all of the questions that have come in. As I mentioned at the start of the session, this session was being recorded and will be available on the DBA Fundamentals archive website in a couple of days' time. And Martin, are you open to having your slide deck added up on the archive site with the recording as well?
Yeah, that's absolutely fine. I put my slide deck up there. I'll blog about that question I got previously about the path. That's something I probably should have had a demo about, so I'll put something up there for that. And yeah, thanks a lot.
Well, thank you, everybody. Make sure you to look at the upcoming sessions for next month, and I look forward to seeing you all again online in July. Thanks, everybody. Stay safe.